I'm Anil Kumar, sharing with you questions where we will understand organized counting, factorials, and permutations. Question number 2. How many two-digit numbers can be formed with following restrictions where digits cannot be repeated, right? So we have a restriction here where digits cannot be repeated. Okay. A is using digits 1 to 9 and B is using digits 0 to 9. So for such questions, we can actually, since the digits are not being repeated, we can apply permutations also, right? Let me begin by simple counting principles, the fundamental counting principle. So what we will do here is two digits, let's say these are the two places, ones and tens. We have to form two-digit numbers from numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have got 9 numbers in all. Now this place, tens place, can be filled by 9 numbers. Since these numbers are not being repeated, so whatever you fill here cannot be filled in the ones place. So we're left with 8, right? Now using the product rule, the combinations could be 9 times 8, which is 72. Do you see that? So that is how we can get the answer, by counting principles, right? So this is your fundamental counting principle. So if there are 9 ways to do one thing followed by 8 ways of the same thing, right? In that case, the number of combinations will be their product. That's the fundamental counting principle using multiplication counting principle. Is that okay? Now, with permutations also you can do it. We have 9 numbers. So we have 9 numbers. 9p, and we have to select 2. 9p2 is the solution, right? So 9p2 means what? 9p2 means 9 factorial divided by 9 minus 2 factorial, which is same as 9 factorial divided by 7 factorial, which is same as 9 times 8, which is 72. Is it okay? So that is how you can do it. Correct. Now let's do part B. You can always pause the video, answer the question, and then look into my suggestions. So we have to form two-digit numbers using numbers 0 to 9. So 0 to 9 means we have 10 digits. Is it okay? Now in the first place, you cannot place 0 because then it becomes one-digit number. So still only 9 numbers can be placed here. But once you place a digit here, maybe 5, you cannot place the same digit in one's place. So you're left with 9 digits, 0 to 9, excluding what you have placed in tens place. Is it okay? So total numbers are 9 times 9, which is 81. Correct? So you can form 81 numbers using digits 0 to 9, which are all two-digit numbers. Do you see that? Okay. Using permutation, also you could have done, correct? So now, in permutation, the idea here is that you are selecting 10 from 10 digits, right? You are selecting. However, so in using permutation, we'll do like this. We have 10 numbers and we have to select 2. However, we'll take away those which start with 0. Since if you start with 0, you get a one-digit number. Is that okay? So it'll be minus 9p1. Do you see that? This is because you take away numbers starting with 0. Is it okay? You take. So if I place 0 here, that is to say, what we do here is that we place 10 digits here, right? 10 and 9 here, and take away those where we start with 0, right? Where we start with 0. Is that okay? So there is 0 is fixed. So here we have 9 options. So we start with 0. I should have written start with 0. 9 options, right? So we just fix this. So that becomes 10p2 minus 9p1, correct? So 10p2 is 10 factorial over 10 minus 2 factorial minus 9p1 is 9 factorial divided by 9 minus 8 factorial, correct? And which is 10 times 9 minus 9. Is it okay? And that gives you the same answer, which is 90 minus 9 as 81. Correct? So it's a bit tricky using permutations. Counting principles give you a very straight answer. And in general, you will see that with working with numbers, counting principles is a good way of going about. I'm Anil Kumar, and I hope that helps. You can always share and subscribe my videos. Feel free to post questions, and if you like, place some likes. Thank you, and all the best.